Hello, my name is Takeshi Emura. I am Associate Professor of Biostatistics Center, Kurume University, Japan. I am introducing my article on dynamic risk prediction via joint frailty-copula model and IPD meta-analysis, building web application. This article is written jointly with Professor Michimae and Professor Matsui. Academic editor of this article is Raul Alcaz. This article belongs to a special issue, Improving Predictive Model with Expert Knowledge, edited by Professor Marcus Pauli. So, what is dynamic prediction? We wish to predict the risk of death as a function of covariates and tumor progression. Here, tumor grows dynamically by either increasing their size or being suppressed over time. The goal of dynamic risk prediction is to incorporate the tumor progression status into a prediction formula, denoted by F. The function F is estimated by individual patient data with survival endpoint. To implement the dynamic risk prediction, we estimate the probability of death at a prediction time t that is placed after the first-line treatment. Then we can understand how the risk of death evolves over time. At time t, a patient may experience progression, which makes a risk of death higher than a patient without progression. This type of dynamic risk assessment may be informative for clinicians to make a decision on a second-line treatment or on a decision on the termination of treatment. Our article in 2018 introduced a formula to calculate the dynamic risk prediction via joint frailty-copula model. This prediction formula is complicated, but can be easily computed by our package called joint cox that is made freely available. If you enter the parameters, you will get the estimated risk of death. However, in order to determine the parameter of the joint frailty-copula model, we need a training data. The training data set that we use is individual patient data from 4 studies. The total number of patients is 720. This table shows the number of patients who experienced tumor progression, death, and censoring. The 4 studies are heterogeneous since the death rate of the first study is much higher than the other 3 studies. We account for this heterogeneity by frailty, and we also account for dependence between progression and death by a copula. So that's why we use the joint frailty-copula model to fit the data. Based on this data, we made an interactive web application. You can click the bar to change the progression time and other covariates. Given the input values, the predicted probability of death is computed and plotted. Therefore, the goal of our article is to introduce how to make this type of web applications via joint frailty-copula model. Thank you for listening.